This is Algebra 1, Lesson 10-17, 10-18, and 10-19, completing the square. Today's date is Monday, May 4th. It's the Star Wars Day. May the 4th be with you. Pronounced that wrong, but whatever. 5/4/2020. Our objective today is to solve quadratic equations by completing the square. All right, so why are we doing 3 lessons in one day? It's because the homework that goes with 10-17 is really easy. By doing just the first 2 steps, you have the homework essentially done, and then steps number 3 is going to be used for the next homework, and then step number 3 again is used for the next homework. You never actually solve because you could just use the quadratic formula, and they want to try to avoid that on Khan Academy. So how do we actually solve a quadratic? There are 3 different things that we do to solve a quadratic. The easiest thing that we can do is ninja star. And I guess I should be putting in here, it's really the advanced ninja star. You should always assume that you use the most simple version of ninja star possible, but sometimes you might be using the advanced ninja star if you have like a leading coefficient other than 1. But the trouble with this guy, and I'll do this maybe in a different color, is sometimes this doesn't work. Sometimes, maybe I should put sometimes in air quotes, sometimes doesn't work. If you're in my classroom, they work out a lot of the time because I like making sure that you know how to factor using the ninja star, but in general in mathematics, they typically don't work. Like 99% of the time, you cannot use ninja star. So then why do we learn that? It's useful for a lot of applications, but these 2 steps down here, they will both always 100% of the time work. Even when you have an answer that is no answer, it will tell you that. So number 2 we just learned, it's the quadratic formula. Quadratic formula. And then finally today is completing the square. Completing the square. SQUARE. And as I said, these will always work. And often in Algebra 1, you see teachers choosing one or the other to teach, and I'm going to be showing you both, and then hopefully you'll like one more than the other, so you'll choose that method. But yeah, they're essentially the same types of things. This one doesn't have a formula for completing the square. It's a little bit more procedural, and if you understand why the procedure works, then maybe it's easier to memorize it. If you can just memorize a formula, maybe step number 2 is easier for you. But here we go. We have 3 homeworks essentially, 1 per day. Our general procedure is a long procedure, unfortunately. But if you understand what you're really trying to do, then the procedure is just 1 step, complete the square, which sounds silly to say, but here we go. Okay, so get into correct form. The correct form that we're looking for is x squared plus bx is equal to c. What is important for this form is that this leading coefficient is 1. So there's no coefficient out front. You'll see in example number 3, we have a leading coefficient out front, so we'll have to get rid of that by dividing everything by 2. The other thing that's kind of important is that this constant term is on the other side of the equal sign. There's only x terms on the left-hand side of the equal sign. Okay, so after you get it into that form, you're going to find the missing constant term, and just doing that will get you the answer for the homework assignment for tonight if you're watching this video on Monday. So the missing constant term is the thing that you're going to add to in order to complete the square, and to find that, you're essentially going to do half, that's a 2, half of the b term. I'm going to put maybe air quotes around that, the b term, and then whatever that half is, you're going to square it. And remember, the b term is the term that's in front of the x right here. Not in front of the x squared, but in front of the x. So whatever that number, that coefficient is, maybe it's 1, so it doesn't exist, but usually it's going to be like an even number to make it nice and easy, because if it's an even number, that's easy to take half of, and then you're going to square it. So it's always going to be positive. I'll put over here, it's always positive. So if you accidentally get a negative for Khan Academy, you've done something wrong. And then this is going to be applying to the second 2 homeworks. You're going to actually add that constant term to both sides, and that's what it means to complete the square. And I'll show you a picture in example 1, and maybe in future examples, on why it means completing the square. It's actually a cool picture to explain that. And then from there you just solve. So typically you're going to have something of the form, I think I have it like down here. Yeah, oh, maybe not. Well, you'll have something squared is equal to a number, and then you're going to square root the square. Okay, so let's move on to example 1. This is very similar to the homework assignment, the first one for 10-17. Just find the constant term, and I'm going to go ahead and first draw a picture. So we know that we have x squared minus 10x, and we want this to be a square. Why do we want it to be a square? Because, I know I'm kind of going on a brief tangent here, but it's important. Because when we have some sort of quadratic terms with an x squared and an x, there's no trick of saying, okay, I can just factor out an x. I guess for this one you can, but typically you'll have something like x squared minus 10x plus 7 or something. There's no x that I can factor out because there's no x in that 7 term. So if I divide everything by x, then I'm left with x minus 10 plus 7 over x, and that's assuming that x wasn't 0 to begin with, and you don't even know that. Maybe I'm dividing by 0 and committing a mathematical sin here. So I can't divide by x. There's kind of no real good way of solving this thing. Maybe I could graph it with a graphing calculator, but even if you craft it, you wouldn't be very accurate. Like, how do you do this with accuracy with algebra to be perfect? And the answer is you have to have some sort of trick using quadratic formula, but before the quadratic formula happened, people used completing the square. And it's a way of making it so that if I can somehow boil this thing, and maybe with a plus 7, into something squared where all the x's are contained in here, there's no x squared, there's like x plus 7 or something. I'm just making numbers up now. If I can contain everything in the square and set that equal to a number, I don't know, 17, I'm just, again, making up numbers, then what I can do is I can square root both sides. If I square root the left-hand side and the right-hand side, I'm left with x plus 7 is equal to 17. And check it out, like, if I get it into this form, then I just have one x. There's no two x's with different powers, power of 2, power of 1, right? And it's easy to solve. So the goal is to get something of this form where I have x plus something squared, a perfect square, in order to solve. So the whole goal of today's lesson is, how do I make a square like this in order to solve a quadratic? And it's called completing the square, because if it was a perfect square to begin with, you already have a complete square. Okay, so finding the missing constant term, let's go ahead and assume, okay, we're trying to get to a square, so let's go ahead and make our square. Our square is going to look like that. Try to make it as squarish as possible, right angles and such. So what do we have? Generally, the square is going to be divided up kind of like this. I guess I can extend these lines too. So we know that the side lengths are what we're trying to get to, but this refers to area. Like, what are the areas of each of these pieces? Maybe the area is 6, maybe the area is x. Well, I know that I have an area of x squared, so I can say, okay, this is going to be x squared. Why? Well, because you can make your picture however you want. This is going to make it easier to see. So 10x, if I put, it's technically minus 10x, so I'm just going to say, if that's negative 10x, and don't write this down yet, this isn't going to be right, because if this is a square, this length and this length should be the same, and they are, because those lengths are x and x. But that means that this length over here has to be minus 10, because negative 10 times x will give me negative 10x. But that also means that this length right here also has to be negative 10, because this length and this length have to be the same. That's the definition of a square, right? Two side lengths have to be the same. So I can't put negative 10x there. I hope you see that, like, if I put negative 10x there, there's nothing that can go here to make sure that these two sides are equal. So I have to evenly divide that 10x into two pieces. So let's undo all of that and say that negative 10x really needs to be divided into this spot and this spot to make sure that these two lengths are the same. So let's put negative 5x and negative 5x for those areas. Negative 5x and negative 5x. So now this is looking more like a square. I mean, this length and this length are the same. It's obviously x times x to get x squared. And then what about the, too far. What about this length right here? Well, x times what gives me negative 5x? And it's negative 5. And then this length is also negative 5, because again, x times negative 5 is negative 5x. Everything in this model looks good so far. Not only does it look good in terms of, yes, you can multiply and get the same area, but check it out, it is a square. X minus 5 and x minus 5, those are the same lengths. Maybe x was 10, so this is a 5 by 5, it is a square. And the cool thing with quadratics is x can be anything. It's a square that has an infinite number of different lengths, because it's x. Okay, and then the question that I have for you is, how do I make this a square? So far I have all of this stuff was given to me. X squared minus 5x is x squared minus 10x. I haven't added anything new into the mixture. I've just kind of figured out, okay, the sides of the square are going to be x minus 5. But in order to complete this square, I need to figure out what value goes there to make it a square. And the answer is pretty straightforward. Now it's just minus 5 times minus 5. Negative 5 times negative 5 is 25. Positive 25, because a negative times a negative is a positive. So what I'm saying here is by adding 25 to this mixture of x squared minus 10x, I have now completed this square, and it looks like a square. The area is a square. So the answer here is 25. By adding the constant term of 25 to this expression, it makes it a perfect square. And not only that, let's take it a step further. I mean, we're done with the homework right now for the first part, and you can stop right here if you want. But what I'm saying also is I know what the side lengths of that square is. So if I now say, maybe I was setting this equal to 0 or something. I'm doing a side problem right now. Let's go ahead and box it done with 25. But taking a step further, what if I had like x squared minus 10x is equal to 0? Maybe that was a problem instead of just what is the constant term. What I'm essentially saying here is, hey, I'm going to add 25 to the left. I'm going to say, hey, plus 25 on the left, and because it's an equal sign, I have to add it to the right to make sure that the equation is balanced, which would mean I have this new equation, x squared minus 10x plus 25 is equal to 0, which seems like it doesn't satisfy our goal. Remember, our goal is to have something like something squared is equal to a number, and I don't have anything like that yet. But I can now, because I know what this thing is. It's a perfect square. It looks like a square, pictorially, graphically. So, well, maybe not graphically, but definitely the picture over here is a square. And what were the sides of that square? Well, it was x minus 5 times x minus 5. Or I can say it, like, it's kind of dumb to say it, but it's x minus 5 times the quantity of x minus 5. That's the same thing as x squared minus 10x plus 25, and the right-hand side is still 0. And a more fancy way of saying that is x minus 5 quantity squared is, wait, why am I putting 0 over here? Sorry about that. Is equal to 25. That 25 hasn't gone anywhere. There's nothing fancy happening over there. Is equal to 25. And that's kind of like where I take a bow. That's the really big trick. I have some quantity squared is equal to a number, and now the next steps I can do step number 4, and I can square root both sides and solve. So I can square root this and get rid of the square, and I have x minus 5 is equal to plus or minus 5 over here on the right hand side. But I'm not going to go that far because I want to show that in example 2. I just want to show you that we have officially used completing the square to solve this type of problem. And the reason why this constant term is so important is because it actually makes this little picture over here a square. So I feel like I'm being maybe too redundant and maybe taking too long to explain this, but let's go on to example number 2. So now I'm actually going to solve by completing the square, and you will never see an example like this on Khan Academy. It'll only say rewrite in the form, and I'll tell you, like, I'll start and say this is where you stop on Khan Academy, and then I'm going to actually go through and complete that. And again, the reason that we don't actually solve by completing the square is because I could just plug this into quadratic, or the quadratic formula, and solve it, and then not have to do any thinking on completing the square. There's no verification that you completed the square or you did the quadratic formula. They'll both give you the same answer. So that's why they make you rewrite it in a form. Okay, so how do I do this? So I'm thinking to myself, I have, so I'm going to strictly go through the procedure, and then hopefully I'll draw a picture off to the side when we have time. So the procedure tells us what to do in the picture, and the procedure says, okay, make sure that I have the correct form. So I need to have this 10 over here on the right hand side, so I have to subtract 10 from both sides. Subtract 10 minus 10. And I feel like I'm acting like the robot that has no idea what they're doing. I'm just following the procedure. So I have x squared minus 8x now is equal to negative 10. Okay, the next step says, okay, I'm going to take half of this b term, half of negative 8. Okay, I'll store that in my memory. Okay, half of negative 8 is negative 4. And I'm going to square that negative 4. So negative 4 squared is, well, anything squared is positive, so 16. So I got 16. That is the missing constant term. That was like the 25 in our last problem that completes the square. And what do I do to that 16? I'm going to add that 16 to both sides. And I realize that it's kind of unclear in my notes why I got 16. It's kind of my scratch work off to the side, but that's how it always is going to be for completing the square. Your scratch work is half the b term, square it, add it to both sides. Okay, well, now I know what the The right-hand side, I guess, is pretty straightforward. This is going to be negative 10 plus 16. That's just going to be 6. What about this left-hand side? And I really should have added it to the notes. It's been a while since I've completed the square, but up here I should say to complete the square, and I should say that your square is going to look like this. It's going to be x minus that 1/2 of b. I don't know whatever that 1/2 of b was. Sorry, x plus 1/2 of b. There's no random switching of signs. Is equal to some number. Oh, I should have a square here. So the main thing I'm trying to tell you here now is, how do I figure out what the square is? It's always going to be the half of the b term, and you can kind of analyze that in the picture down here. We said we had negative 10x, which means the b term is negative 10. Half of negative 10 is negative 5. That's why we had x minus 5, x minus 5. So I'm always going to be doing half of whatever term I'm given for that b. So my b term in this case is negative 8. Half of negative 8, I already wrote over here, is negative 4. So this is going to be x minus 4 squared is equal to 6. X minus 4 squared is the same thing as x squared minus 8x plus 16. They are the same. If you actually FOIL this out or use the box method to multiply x minus 4 times x minus 4, you will verify that these two are the same. This is just a shortcut. It's the half of the b term. And then from here, you're done, right? On Khan Academy, you'd say, yep, on Khan Academy, start, and that's a horrible start. Can I please try to do that again? Slightly better. On Khan Academy, this is what you're going to enter in. But I'm going to mathematically show you what you should be doing for the next step. So next I should be taking the square root of both sides. Take the square root. And when I take the square root of a square, these two cancel each other out, and I'm left with x minus 4 is equal to, okay, when I square root, I'm always going to write plus or minus square root of 6. And then from there, I'm going to add 4 to both sides. So x is equal to, I'm going to add 4 and then plus or minus the square root of 6. And those are the two answers. And I would have gotten this from quadratic formula also. Notice that it had a square root in it, which means I couldn't factor it using Ninja Star, just like the vast majority of quadratic problems. And I realize this video is already really long, and I'm anticipating, because it's spread across 3 lessons, it's okay to be long, and I'm getting that conceptual understanding, but I want to draw a picture of what was happening here so we can really visualize, why does that procedure make sense? And maybe you're already getting a glimmer of it, or maybe you already understand all of it from the first example, but why did I take half the b term? Why did I square it again? So let's go ahead and draw our picture one more time. I don't think I'm going to do a picture after this, unless you really want me to, but I don't have that feedback. So my picture is going to look kind of like this, where I know that I have an x squared term. So that x squared term is going to go right here. And I'm going to have this length is x, this length is x. What else do we know? I know that I have negative 8x. And I'm assuming that I'm kind of starting from this problem right here, where I have x squared minus 8x, and I don't have to worry about the negative 10. And in fact, I could actually make this picture where I have that negative 10, or that, sorry, I have that positive 10 in it too. It doesn't really matter. But I know I have x and I have x. I know I have a negative 8x. That needs to be evenly divided between these two spots in order to make these two segments the same length. So that is the main reason why I'm taking half of the b term. Half of negative 8 is, or negative 8x is negative 4x, and negative 4x, I think that you guys can all agree that this area here adds up to this area right here. And then from that, I know the side length here must be minus 4, because minus 4 times x is negative 4x. And then similarly, this has to be minus 4 to make this length and this length the same length to make it a square. And then I'm going to take, after I took half of the b term, negative 4, I'm going to square it, because what fills in the area here is negative 4 times negative 4. So I'm going to say the term that I'm going to be adding to both sides is 16, and that is the term that I added to both sides. And then from there, it's just pure algebra, just solving. The cool trick is this square is represented by x minus 4 times x minus 4, or x minus 4 squared. So kind of cool there, but nothing too fancy. So the picture makes sense, and I really don't want you to think, at least the way that I would, in the ideal world, what I expect of you guys is, don't memorize this procedure. I mean, you can if that's your backup and you're really not liking what's happening in this math class right now. Really what I want you to think about is this picture. Think of this picture either mentally or write it down and say, okay, I have an x squared term. I know that I need to evenly divide that b, this negative 8x, into these two segments, and I'm going to square that to get that segment. And that's why I'm adding 16 both sides, and then hopefully you'll remember how to do the trick with the side and square roots and all that stuff too. Okay, so On to example number 3. And by the way, this is now moving on to the hard homework. So this is going to be like lesson 10-19 essentially. How do I do it when I have a problem like this? And why does this problem look different? There's a few things. First, there's a 2 out front. And remember, as I talked about all the way up here, you need to make sure that you have a 1 out front. So it has a 2 out front, and not only that, I made this really gross. I made it -7, which is not an even number. So even after I divide everything by 2 to get rid of this 2, I'm gonna have to divide by 2 yet again. This is gonna be a gross decimal, and they happen in Khan Academy, so I'm gonna get you ready for them as well. So here we go. First up, I'm going to divide every single term by 2 to make sure that this leading coefficient is 1. So divide this by 2, divide this by 2, divide this by 2, 0 divided by 2, 2, I guess. It doesn't really matter. 0 divided by 2 is just 0. So down here I'm going to say, okay, this is now x squared minus, I'm going to go to decimals because fractions are going to get really hard really fast. Negative, well, actually, it might be easier with fractions. Hold on, let's try fractions. You can use decimals if you want. This is going to be -7/2 x plus 3 is equal to 0. Again, 0 divided by 2 is 0. Okay, so next I'm going to subtract 3 from both sides. So that's going to be x squared minus 7/2 x is equal to -3. I subtracted that 3. Okay, so from here, procedurally, I'm thinking of that rectangle. I know I have to divide this -7/2 between those 2 spots, so I'm dividing it by 2. And if you want to do some side math, 7/2, if I'm dividing that by 2, that's really saying -7/2 times 1/2, because keep it, change it, flip it. And then when I do that, I multiply the tops, -7 times 1. -7. 2 times 2 is 4. So -7 7/2 divided by 2 is -7/4. So that is half of the b term. And then I'm going to square that. So coming down here, doing a different color, -7/4 squared means I'm going to square the top. 7 times 7, 49. It's positive because everything squared is positive. And 4 times 4 is 16. So this is the term I'm going to be adding to both sides. So I'm going to add 49/16 plus 49/16 to both sides, and that completes the square. So what does this become over here on the right hand side? Again, I have to do some more scratch work, because I'm doing 49/16 minus 3. And minus 3 is the same thing as if I multiply by 16, multiply by 16. 16 times 3 is 48. So this is going to be 49 minus 48 all over 16. And that's 1/16. Whoa. Okay, I totally picked these numbers at random, and that came out way, way nicer than I thought. And you'll see why in a sec. So I've added these two, and I got 1/16. So over here on the right hand side is 1/16. And over here on the left hand side, you can write this all out again. I could just rewrite x squared minus 7/2 x plus 49/16, but that's a waste of a step. So I'm going to go ahead and write out what the quantity squared is. And how do I figure that out? Again, it's going to be x, and then you're going to do minus or plus half of this term, essentially this term right here. Remember when we took half of -7/2 and we got -7/4? Yeah, we're doing that -7/4 right here, -7/4. And this is, I'll start, this is the thing that you'll enter into Khan Academy. This is your answer, you're done. And that was a hard version of it, and it is hard because there's fractions, maybe decimals if you went down that route. I have a feeling if they have you entering it exactly, you might have to be doing fractions. They might force you to do fractions, so be wary for that. Wary and ready, I guess, same meaning. How do I actually solve this though? I'm super curious. How would we do this? And that's the reason why it works out so nice, so check this out. I'm going to square root both sides, square root and square root. And when I square root the square, those cancel out, and I'm left with x minus 7/4 is equal to, and this is why it worked out so nice. So always plus or minus whenever you square root, but the square root of the numerator and square root of the denominator is the same thing as the square root of the whole fraction, right? So the square root of 1 is 1, the square root of 16 is 4. That got even nicer. Like, that was so cool. Both of them were perfect squares. I did not plan that at all. Although maybe I should feign that I did. Oh man, I'm so smart. Yeah, look, nice problem. Okay, so from here I'm going to add 7/4 to both sides. So x is equal to 7/4 plus or minus 1/4. And I'm realizing that those numbers are actually kind of nice. Typically, we even end there, and I'm going way too far. I know. Mr. Snell, stop doing math. So when I add 1/4, this is going to be 8/4. When I subtract 1/4, this is going to be 6/4. And these both reduce to 2 and 1.5. So kind of nice answers there, right? Those are the zeros, I guess, of our equation. Whew, okay, so now example number 4. So this guy is a little bit different because it wants you to rewrite it in a new form. Just like up here, it probably has kind of the same instructions. Rewrite it in this form, and then you kind of get to this step. And this is something that seems totally unrelated to solving, though. And it's very useful when you get into the lesson. It might come up in 10-20. I haven't looked ahead that far, but when you have to like graph it in standard form, you might have to do something like this. So be prepared. This is kind of like turning it back into vertex form, which again, you can look back on the webpage if you forgot what vertex form is. So it's essentially the same process though. So again, I don't like this because there's a 4 up front. So the very first step is I can't just divide everything by 4 because I don't have a value over here. This is just h of x, so I have to factor out a 4. Okay, Shift Z. It didn't get rid of. Okay, so I accidentally undid too much. Sorry. I have to factor out a 4. So what that means is I'm going to keep this as h of x. That's always going to be the left-hand side. But the right-hand side, the 4 is being factored out. And what's left over? Well, 4x squared divided by 4 is x squared. Negative 24 divided by 4 is negative 6x. And 120 divided by 4 is 30. And so I'll give you a warning, a heads up. On Khan Academy, they frequently make these weird fractions right from the get-go. I kind of made this one too nice. But whatever. Like, I think you guys kind of get it by this point. I'm already like 27-ish minutes into this video. So I made it so that this leading coefficient is 1, and you can probably see, like, since I factored out a 4, this leading number out here is going to be a 4, and you're done, right? You know that number. Okay, so next I need to, can this actually be solved using Ninja Star? I might have accidentally done a solvable problem. Let's think. 30, factors of 30, 1 and 15, 2 and 15, 3 and 10, 4 and... No, it doesn't work. 5 is, okay, so maybe this does need to be used. Okay, it's just musing to myself. Okay, so again, taking half of the middle term, which is -3. So I say -6 divided by 2 is -3. And again, I'm going to be using that -3 whenever I write it in the square form. And then I'm going to square that. So -3 quantity squared is 9. That's the number that I'm going to be, quote unquote, adding to both sides. But again, I can't add that to h of x. I can't add anything to this side. I'm kind of restricted. But what I can do is I can move this 30 out of the parentheses. So I can say the new equation looks like this. H of x is equal to 4 times this quantity of x squared minus 6x, and then kind of like plus 30 is out there. What I really want is a positive 9 in here to complete the square, right? But I'm not allowed to just add 9 wherever I want to, willy-nilly, right? So, well, what's going on? My computer's like frozen. There it goes. I can't just add 9 wherever I want. I have to both add 9 and subtract 9. If I add 9 and subtract 9, I'm net adding nothing. I'm not doing anything. So that's the cool trick that you're doing here, and everything else kind of just flows from here. So from here, my next step is going to say h of x is equal to 4 times the quantity of, and it's kind of a waste of a step to rewrite this, so I'm going to go ahead and write it in squared form, so something quantity squared, and then this number out here is just going to be 21 plus 21, and hey, look at us, we solved for that number, 21. And then this term in here, again, you're going to be using the half of the b term, -3, so it's just going to be x minus 3. X minus 3. And hey, we solved for this one as well. It's going to be a -3, which is kind of weird to say plus -3, but there it is. And there's your final form that you're looking for. And this one isn't asking us to solve for x, so we don't have any more steps. This is the end on my problem, and it is the end on Khan Academy as well. So go ahead and box it. Cool. Yeah, one of my longer videos, but hopefully you guys took something away from this more than just how to complete the square. Maybe a process, like how to connect a picture to a process is the main takeaway I was hoping for. But yeah, that's it. That concludes Algebra 1 Notes 10-17, 10-18, and 10-19. I'll see you guys tomorrow.